Hello guys, welcome to another section of Math. Today we are going to look at how to solve indefinite integral with the denominator being what in the form of polynomial and not what quadratic expression. If this denominator here appears to be in the form of quadratic expression, our problem could have been easy. We just factorize and then we decide the approach to use. But here is the case, the denominator here is in the form of polynomial. So how are we going to do it? Well, what I will say is when the denominator, the problem that you are to solve, the denominator is in the form of polynomial and not quadratic expression, will depends on the type of polynomial that you are having. If yours is more than 3, the approach that you will give to this one will be different from the approach that you give when the polynomial is more than 3. Here I can tell you we are going to maybe factorize, but assuming if the expression here, when you count them and you get it's about maybe 4 or maybe 5, maybe factorization won't be possible. Yeah, I would say maybe because factorization won't be possible because for some polynomials, before you can factorize them, you have to reduce it. You have to reduce it before you can factorize. But this one here, we will not bother reducing anything here. We can factorize it straight away. Okay, so what I will say is that the approach that you give or you apply when the denominator is in the form of polynomial will depends on the nature of that particular polynomial. So the approach we are going to give this one will be different from assuming if there is more plus maybe s cube or plus something blah blah blah. So the approach that you give when this one is more than 3 will be different from the approach that you give when you apply when this one is let's say less than 3. So it depends on the nature of the polynomial. Okay, so here ours is 3, that is x raised to the power 4 plus 18x squared plus 81. So how are we going to deal with this one here? Well, to find out, let's get started. Let's write our solution first. Now let's bring this one down here. Good. Well, here, what are we going to do? Well, before we can decide on what to do, we need to do certain things. Here we are having 81, and here there is x squared here, and here this one too is 18, and here is x raised to the power 4, meaning that even if this one is not there and we are to consider this and this, it's still polynomial, and we are to consider this and this, meaning that x squared is here and we are having x raised to the power 4, meaning x squared can come out, right? But now, sorry, let's put the assumption somewhere. There is 81 here, so how are you going to do it? 81 is the same thing as 9 times 9, and this 18 here is also the same thing as 9 plus 9. This x raised to the power 4 here is the same thing as x squared times x squared. So now that we know how to manipulate each of the variables and numbers here, why don't we try factorizing? Because we know that this one is 9 times 9, and this one is also as 9 plus 9. and this one is the same thing as well, x squared times x squared. So when we write this one as 9 plus 9, we know that on this side 9 can divide this one, and then on this side x squared can divide this one. So when you write this one as 9x squared plus 9x squared, it will help what? It will help, in what? Factorizing. Okay, so now let's write this 18 here as what? 9 plus 9, but it's not just any 9, but rather 9x squared plus what? 9x squared. Okay, so let's write this one as well, 9x squared plus 9x squared. Good. Now when we write it as 9x squared as 9x squared, now as you can see, when we are doing I said we have to do certain things before we factorize. Now 9x squared plus 81. Now when we bracket this one and then we decide to find what a common factor here, you just leave x squared alone because it doesn't have anything common here. But 9 can goes into 81. That means 9 can come out. 9 is a common factor here, right? Good. Now on this side we know what is going to come out. Let's come here. This side too, we will just leave the 9 alone. X squared is here and x raised to the power 4 is here. So meaning that x raised to the power 4 is here and x squared is also here. Meaning that x squared, when you bring x squared outside, it can divide this one, so we can bring x squared outside. And definitely when you bring this one outside and this side we bring 9 outside, those what is going to remain in the bracket will definitely be the same. Okay, sure. So now our factorization is what? Possible, because we know those that are going to come out and those that are going to remain in the bracket. So let's factorize. So we are gonna bracket this and also bracket this and that. Okay, so let's do that. Now here, as I said, what is going to come out here is x raised to the power 4. So we just leave this 9 alone. So we just bring x outside. And when x come out, x raised to the power 4 divided by x squared will give us what? That will give us what? X squared. So what is going to be in the bracket is going to be x squared plus 9. Let's come to, there is no x here, so let's leave this x squared alone. Now 9 is here and then we are having 81 here, but 9 can go into 81, so just bring 81 outside. When you bring 81 outside, this one will no longer be 81 anymore, but rather it will be 81 divided by 9, and that will give us what? 9. Okay, so this side you're gonna get x squared into bracket x squared plus 9 plus 9 into bracket x squared plus 9. You see, what is in the bracket has become the same. So we just pick those that are in the bracket, and then we pick those that are outside the bracket, and then we bracket that one as well. Okay, good. As I said, you can see that this side and then this one and this one are the same. So what are you going to do? Yeah, let's just pick this one and then this one and bracket it as well. But since this and this are the same, you just pick one of them and then we multiply by the bracket of this and then that. Okay, good. Now x squared plus 9 times x squared plus 9. This and this are the same. So this and this can be written as what? X squared plus 9 all raised to the power 2, because we are having the same thing here, and it is 1, 2. Okay, it means this one is multiply itself for 2 times, and from indices, when it happens like that, it can be written as what? X squared plus 9 can be written as what? X squared plus 9 raised to the power 2. Okay, so let's do that. All right. Now that we have been able to factorize the denominator or factorize the polynomial, what are we going to do? Being able to factorize the polynomial does not mean we have solved the problem. The problem is still the same, it's just that we have managed to reduce what its difficultness. Yeah, we have managed to reduce what its difficultness. The nature of the problem has been adjusted a little. Yeah, we have taken it from what the maybe polynomial position to let's say a quadratic position. We know more about how to handle with, let's say, quadratic expression as compared to a polynomial. So we have managed to change it from the quadratic position to the polynomial position to quadratic position, so that we can um, deal with it better. So that we have managed to factorize the polynomial, what are you going to do? What approach are you going to use? Okay, looking at this one, what approach are you going to use? Partial fractions. Will partial fractions work? Well, I will leave that one to you guys. Maybe you can try partial fractions to solve. You can try partial fractions, and when they work out, please kindly do well to leave in the comment section for me to also know. Okay, yeah, you try solving this one using partial fractions. So maybe any other approach that you think it can work out apart from what I'm going to use to solve this one in this video. Maybe when you do and it work out for you, you let me know in the comment section. But here I'm not going to use partial fractions, neither am I going to use um, substitution or maybe integration or apart, but I'm going to use trig substitution. But before we can use the trig substitution, we have to know how this one is going to be written on the sides of the triangle. Remember the other time I told you that when what you are going to write on the side of the triangle is what? Subtracting. The treatment is different. And when it is adding, the treatment is what also different. Now, when it is subtracting, maybe square root of something minus something or something minus something, and you are using trig substitution. When you draw your right angle triangle, what should come in your mind, or the moment you see that it is subtracting, what should come in your mind? That the one that is something being taken from is going to appear on the hypotenuse. So the moment you see that it is subtracted, what comes in your mind is what? First should be what? The hypotenuse side. The hypotenuse side. That is, one is going to be on the hypotenuse, and then the other one that is being subtracted from. Yeah, I mean the one that we are taking from the other one, that one is just going to be on the one of the sides of the triangle, apart from the hypotenuse. So what the point that I'm trying to make here is that the moment you see, in terms of using trig substitution, the moment you see that what you are going to write on the side of the triangles are subtracting, the first side to locate, or the first side to think of is what? The hypotenuse. The hypotenuse. That is, the one that we are taking something from is going to the hypotenuse side, and the one we are taking from the other one will go on maybe either the opposite or maybe what? The adjacent. Okay, and also when it is adding, we don't think of the hypotenuse. You see the difference? When it is what? Adding, forget about the hypotenuse and concentrate on the other two sides. That is what? The opposite and what? The adjacent. Because from the Pythagoras theorem, opposite square plus adjacent square will give you what? Hypotenuse square. Okay, so when what you are going to write on is what? Adding, You shouldn't worry about the hypotenuse anymore. What you should focus on is what? How to write it on the opposite on what? The hypotenuse. One of them will be on the one will go on the opposite and the other one will go on what? The adjacent side. Okay, so here we are having x squared plus 9, meaning it is going to appear on the opposite and the what? The adjacent side. And the application of the Pythagoras theorem will just bring what? The hypotenuse side. Okay, so our main focus is going to be on the opposite and the what? The adjacent side, because a squared plus b squared will give you what? Square root of 4a squared plus b squared. Okay, so here you are going to write this one on the sides of the triangle. When you are going to do that, forget about this one. If this one is a perfect number, I mean something that when you square it will give you what? The whole number. Square it. Now when you come to this one, forget about the x square, just pick x. I said this one square it because if it is in the form of, let's say, 81, you can't write the whole 81 there. When you write the whole 81 there, definitely at the end of the day you are going to apply Pythagoras theorem. So when you apply the theorem, you will get more than what? The 81. So you have to square it, because you have to square it so that when you apply the Pythagoras theorem, you will get what? Your 81 back. Okay, so here is what? 9. Square root of 9 will give us what? 3. So we would rather use 3 on the sides of the triangle rather than 9, because when you square 3, you're going to get this 9 or back. And this one to the same thing. When we use x squared, you're going to get something different. But when we use x, you're going to get x squared or back. Okay, so as I said, we are going to use trig substitution. All right, so let's draw a right angle to reflect what I'm saying. So this is a right angle triangle. And now, remember what I said. When it is subtracting, you first think of this side, okay? And when it is adding, you just think of this side and then what? This side. Our problem here is what? Adding. It is what? Adding. So we are just going to focus on this side and then this side too, okay? But before that, before we can know what is going to come here or here, you should know what is this side and also what is this side by positioning our angle or theta. So we are going to bring our angle theta here so that we can know the names of what? This side and then this side. So there is our angle theta here. So now that theta has been located nicely, we know that this side is what? Our opposite, and this side is what? Adjacent. Okay, so here x squared plus 9, as I remember, you take square root of what? 9, and that will be 3, and x squared will just pick what? Our x. We are going to write x here, and then we will also write 3 here, and from the application of Pythagoras theorem, x squared plus 9 will just come to this side. Okay, so let's put our x here, and then here we just put our 3 here. Now this squared plus this squared will come here, but remember we take square root of that. Okay, so square root of what? X squared plus what? 9 squared is coming to this side, all because of what? The application of Pythagoras theorem. Good. So now how are we going to form our ratios? We are going to form our ratios by using the formula of what? The ratios. Now remember the other time I said that when you are generating your ratios, always make sure you go for those that are what? Simple to differentiate. Okay, so here it's going to go for those that are what? Simple to differentiate. Okay, now when we use sign, it will be this one over this. Differentiating is easy, but it will take a little bit long. When we take cos, it will be this over this, same problem. Why don't we try tan? Tan will just be this one over this, and x over 3. When you are differentiating x over 3, that one is more easily than differentiating x over square root of x squared plus 9, right? Good. So tan theta will be equal to x over 3, and x will be equal to 3 tan theta. Good. Now, when we get back to the integral, we are going to put x is equal to 3 tan theta there. Okay, so we know that in the integral, in the theta word, we are going to replace this x with what? 3 tan theta. But what is going to replace what? Dx. Okay, so let's differentiate this one to find what is going to replace what? Dx. When you differentiate this one, you're getting what? Dx. And when you differentiate this one, you're gonna get, forget about this 3, differentiate this one, you're gonna get secant theta squared. Then you multiply it by this 3 here, and that is going to give us 3 times secant theta squared. Okay. Okay. Now, what is going to replace dx has been found. That is what 3 secant theta squared. The theta will replace what? Dx. So now let's replace them in the theta world. Good. Now remember here was what? X squared, and x squared is equal to 3 tan theta. So that is why this one is here. And this side was what? Dx, and dx is equal to 3 secant theta squared, the theta. That is why this theta is here, and that is why this one also here. Actually, it is multiplied, but when we multiply, you're gonna get the same thing as well. This, so that is why I write this one straightforward for you guys. Okay, let's open this bracket. 3 tan theta all squared will give us what? 9 tan theta squared. 9 tan theta squared. 9 tan theta squared. Alright, good. So 9 tan theta squared plus 9. Okay, so here we're just going to do another factorization. We are having 9 here, we are having 9 also here. So we are going to bring this 9 outside here. But take note of something. When you are having something like a plus all squared, and you want to take, let's say ab plus ac all squared, and you want to take a outside, remember that the square is already affecting the a. Remember it was ab and then ac, and it's all what? Square. So if you want to take one out, you have to take it out together with what? The power 2. If you ignore the power 2, you are wrong. So if we want to bring this one, or if you want to factorize this one by bringing the 9 outside here, we cannot do so without these 2 here. We have to add the 2 to this one, because already this one is what affecting it. So here is the case, we are taking out without it, meaning we are doing something different. So when you get something of this nature and you are factorizing, make sure whatever that you bring it outside, you also what? Square it. Okay, so we are gonna bring 9 outside here, and it won't be 9, to be what? 9 squared. 9 squared. Okay. Now when you bring 9 outside, you're gonna get 9 squared as you're gonna get tan theta squared plus 1. Tan theta squared plus 1, all raised to the power of 2. Now 9 squared will give us what? 81. And this one, from trig identities, we know that tan theta squared plus 1 is equal to secant theta squared. So you're going to replace this one with secant theta squared. Okay. Good. Now when you replace that one with secant theta squared, you're gonna get secant theta squared all raised to the power 2, and that will give us what? Secant raised to the power what? 4. And 9 squared is the same as what? 81. Okay, so how are you gonna do that? Well, you can do some cancellation here. This 3 can goes into this 81, and that will give us what? 27. Now we are having secant theta squared, and here we are having secant theta raised to the power 4. So this one will reduce this one by 2, and here will give us what? Secant theta squared. Okay, so you're gonna get 1 over 27 times secant theta squared, and that 1 over 27 will go will come at the back here. So you get that 1 over 27 well here. Okay, definitely we will just bring it at the back of the integral sign. All right, now from the trig ratios, the reciprocal of cos is what? 1 over cos, and that will give us what? Secant. So the reciprocal of secant is what? 1 over what? Secant, and that will give us what? Cos. So from this, 1 over secant theta will give us what? Cos theta squared. Cos theta squared. Cos theta squared. Good. So how are you going to solve this one? This one too, we are going to apply the same trig identities. We know that if you want to integrate the even power of trig ratio, you have to use the even power rule. That is, sine theta squared is equal to half plus half times cos 2 theta. So the same thing. Oh, sorry, for sine it will be minus, but for cos theta it's going to be half plus half times cos 2 theta. If it is x, the same thing, it's just a matter of changing or the variable. Okay, so here we're going to replace this one with what? Half plus half times cos 2 theta. Okay, all right. Here before we integrate this one, let's factorize and bring this half at the back here before we integrate. Okay, so here we're gonna factorize and bring the half at the back here, and when you do that, here you're gonna get 1 over 27 times 1 over 2, and that will give us what? 1 over 54, and here we'll be left with 1 plus cos 2 theta. All right, 1 plus cos 2 theta, the theta. Now, this one, we all know the answer to this one, so we will not bother splitting. The answer to this one, we all know. The answer to this one, we all know. So we are just going to write it straightforward for you guys without doing any further substitution, thinking of what is going to be. No, I'm just going to write the answer to this and this one as well. Now, when you integrate theta, when you integrate 1, you are going to get what? Theta. Now, when you integrate cos 2 theta, first of all, you have to, it's going to give us 1 over 2 times sine 2 theta. Sine 2, and you know why? When you do substitution, this one, u is equal to 2 theta. When you're gonna get theta. I'm gonna get 2 theta, and then divide both sides by 2, then you get the theta is equal to 1 over 2 du. Now when you integrate cos u, you are going to get sine u, and sine u times 1 over 2 give us what? 1 over 2 sine u. And what is u? U is equal to cos 2 theta. Good. So Well, here what we are going to do is here is that sine 2 theta can also be written as from the double angle formula for trigonometry. Double angle formula, sine 2 theta is the same thing as 2 sine theta cos theta, or 2 times sine theta times cos theta. Okay, so this sine 2 theta here can be written as, or is the same thing as 2 times sine theta times cos theta. Okay, and when you do that, this half times 2 will give you what? 1. The 2 will cancel out with this half, and to be left with sine theta and then times cos theta. Okay. Okay, so as I was saying, this one can be written as what? 2 sine theta times cos theta. Now these two will cancel out with this one to be left with 1. And when that happens, you're gonna get theta plus sine theta times what? Cos theta. Alright, so let's open the bracket. So here it will be 1 over 54 sine theta plus 1 over 54 times sine theta times what? Cos theta. Alright, guys, the answer to the integral question we started solving in the theta world is 1 over 54 times sine theta plus 1 over 54 sine theta times what? Cos theta. So that is the answer in the theta world. But here is the case, the problem is not an indefinite integral, so we have to go back to the x world. So this is the answer to the problem in the x world. But what is the answer in the, this is the answer in the theta world, but what is the answer in the x world? Well, now that we know the answer in the theta world, let's change the answer to um let's change the answer from theta world to x world. Okay, so going back to x world, we have to know what is going to replace sine theta, cos theta, and then tan theta. And to do that, or to be able to know what is going to replace theta, sine theta, cos theta, you have to go back to the right angle triangle that you sketched. When you get there, you just apply the ratios. Sine theta is equal to what? Tan theta is equal to what? Then when you apply the ratios, whatever you get, remember you form equation, so whatever you get, you just replace that ratio with whatever that you get in the x world. Now when you go back, what is sine theta? You just look at the triangle, form the ratio, that is what? Opposite over what? Hypotenuse. So we just look at that one and then we replace that one with what? Sine theta. And the same thing for what? This, and the same thing for what? This one. But because I'm not going back to show you the right angle triangle, I'm just going to write what is going to replace this one. What is going to replace sine theta, cos theta, and then theta in the x word for you. Okay, but when you go back, what I'm going to write here for you, when you sketch your right angle triangle and you are going to find what is going to replace, just going to get the same thing as what I'm going to write here for you. Okay, but I'm just trying to tell you how you are going to get what is going to replace them. Okay, so let me write that one for you. Okay, but we know that tan theta is equal to x over 3, sin theta is equal to x over square root of x squared plus 9, and cos theta is equal to 3 over square root of 4 x squared plus 9. When you apply the formula for these, you will know that these answers to each and every one of them is what? Correct. Okay. All right, now that we know what is going to replace sine theta, cos theta, and then left with what? Theta. Okay, from here we are having tan theta is equal to this, so we can make theta the subject by taking tangent inverse of both sides. Okay, so when you take tangent inverse of tan theta, you're gonna get tan theta, and when you take tangent inverse of this one, you're gonna get tangent inverse of x over 3. Okay, good. So we're gonna replace theta with tangent inverse of 4 x over 3 sine theta with this one, and cos theta or with this one in the x world. Okay, now let's replace it. Good. Now when you replace them, that is what we are going to get. Now that is the answer in the that is the answer in the x world. But let's do some cancellation. Let's try and reduce something here. Here having 1 over 54 times x over square root of x squared plus 9 times 3 over square root of 4x squared plus 9. They are all multiplying. So this 3 here can goes into 54, and that will give us what? 18. So you're gonna get this side will be what? 18. Now this times this will give us what? This square root of x squared plus 9 all squared. All squared. Good. Now here, this will take away the square root sign to be left with what? X squared plus what? 9. Okay. And then, now when you come here, well, just leave it as it is. So here, this will cancel out with this square root sign to be left with x squared plus 9. Okay. And then we definitely going to multiply the 18 through. Alright. So here in the x world, each and every one of these is an answer in the x world. Yeah. Since we are done with the integration, whatever that you are seeing here is answer to all the integral question. You can leave it here. You can also leave it here. Who knows? Okay, or B, what we are doing is just to reduce the answer to each lowest term. When you leave it here, you are not wrong. That is the answer to the integral question. You are not wrong. When you leave it here, the same thing. When you leave it here, the same thing. But all the jumping from here to here to here, or moving from here to here to here, is just a means of reducing the answer to each lowest step. Okay, yeah, it is a means of reducing the answer to the lowest step, or maybe trying to do some computation to get what to reduce the length of the number of answers that we have gotten. Okay, so if you leave it here, I will not say you are wrong. You are correct, because all of us, we don't know how the solution is going to be work out. So if you leave it here, you are correct. When you leave it here, you are correct. You also leave it here, you are also correct. But I would prefer that, I think, when you are done with the integral, try as much as possible to do some computation to reduce the number of the length of the answers, or the number of answers that you have gotten, provided you've gotten something of this form. Try and reduce it. Okay. All right, so here we can leave it like this. You are correct, or maybe multiply this one through open the bracket. So, well, if you want to open the bracket, then let's move on. So you're gonna multiply this through. So this time this will give us what? 18 x squared, and 18 times this one will just give us what? 100, and I think it's 162. Yeah. All right. So 1 over 54 tangent inverse of x over 3 plus x over 18x squared plus 162. This one here is the answer to the integral question that we are solving. Okay. The other one, those ones that we started seeing in the moment we enter the S word are all answered, but this one is well the lowest term to 8. Okay, so let's end it. Therefore, interface integral of 1 over x raised to the power 4 plus 18x squared plus 81 dx is equal to, actually it's equal to any of the answers in the x world or in the u world, but here we are equating it to the lowest term of the answer. Okay, so it's equal to 1 over 54 tangent inverse of x over 3 plus x over 18x squared plus 162 plus c. Okay, all right guys, now I do hope that most of you have now gotten to know how to deal with polynomials in the denominator's position in terms of integration. But I will not say all polynomials when you are integrating them and they are of this form, the approach that we give you to this one is the same thing as applied to this one. Okay, sometimes, remember I said you have to do certain things. You have to find out if the factorization will work. At least this polynomial here is different from the polynomial that we will be having, but what I said, do some check, find out if the factorization is possible. That one will help you deal with the factorization of any polynomial, or deal with any polynomial that you come across when you are integrating. Okay. All right. That's it, guys. Please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching, and I will see you in another video. Bye for now.